Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to all of you for our new live webinar today, and I should say to our TV program, FeedChannel.online. As often as possible, we try to address your concern from the practical issue to the scientific basis, with experts from all over the world, from the academia as well as from the industry. Each webinar starts by a situation in the field, and after we try to have an explanation on the fundamental basis with experts, and we organize a roundtable to allow you to ask any questions to our invitees during the sessions. Since our previous webinars, we have posted a lot of documents and events on the FeedChannel platform. You could see the first Advancia Academy organized in Barcelona prior to the European Symposium on Poultry Nutrition, with a nice presentation from Massimiliano Petracci. And we have also interviews during the ESPN to show, in fact, the large attendance we had this year at the ESPN. We have also new events coming soon. We have recently recorded the keynote speeches at the IC conference, the Gut Health conference, or Intestinal Health Scientific Interest Group conference, organized in Bangkok 10 days ago, and this will be posted early next week. So it's very interesting. And it is our fourth FeedChannel live webinar today, and we are really pleased to welcome so many participants. And I just remind you that you can post any question during the webinar today at any time, and they will be addressed during the roundtable sessions. And if your question has not been answered today, you will get the answer on the FeedChannel platform. So many conferences and congress on meat quality issues addressed the breast meat myopathy recently. So over the last 2 years, I would say, most of the conference addressed these issues. So the wooden breast, the white stripping, the deep syndrome, the green muscle, and also the spaghetti meat I learned from Massimiliano. And we think that scientific progress are undergoing actually at the research institute and so on. And one main comment on issue observation we saw is actually it's an issue related to oxidative metabolism. When I say oxidative metabolism, it does not mean that it's a problem of oxidation. So people trying only to put antioxidants did not solve the issues. But really, there is a link between the oxidative metabolism and the function of the mitochondria may be related to the energy metabolism. I'm sure that Cecil Berry will further comment on that later on. But we decided maybe not to continue to focus on that topic, which is very hot topics today, but next year it will be even more interesting because we will see progress. But it is also important to address some issues that still remain a very big concern, what we call the losses. The drip loss, the cooking loss, and all the loss related to the meat during the preparation and during the processing and during the storage, and also the meat color, and particularly the meat color change during the storage. I am pleased to welcome today two well-known scientists and a representative of the poultry industry. And I will start with the lady, Dr. Cecil Berry, from INRA in Tours in France, as director of the Poultry Research Unit, or Avian Research Unit, who developed lots of work on the meat quality, and she continues even with managing the whole lab to continue to be investigating on meat quality, and particularly on the relationship between nutrition, genetic, and the meat quality issues. And I think it's she will give a bit more understanding of what she's working on later on. And Professor Massimiliano Petracci from University of Bologna in Italy. And everybody knows Massimiliano because he talked at many conferences about this breast myopathy, the wooden breast, and the white stripping. And I would say I've learned earlier on in Edinburgh at the egg meat conference about the spaghetti meat, and I realized it's not positive to have the meat and the spaghetti at the same time. So I think it's a good to have some of the better explanation on that with Massimiliano. And I would like also to introduce people from the field, from the slaughter plant. Paul, as a representative of the European Poultry Processor Association. He is also working for LDC, the French leader in poultry production, and he will talk directly from the slaughter plant. So, by the way, it's a good time maybe to address the first question to the processor. What is the current field situation regarding those issues? So I will ask Paul, what do you think about that from the practical point of view, from the field situation?
When we are speaking about meat, because I am in a slaughterhouse, we can say that water content since many years has been increasing. We have not on our side, on our industrial side, not any figures explaining what was the increase of water content of the meat, but as it has increased, we have more drip loss than we had before.
And if we look today at the economical consequence, because you try to evaluate what could be the impact of all these losses on the economy of the poultry chain, it's very hard to find data in the literature. So we try to illustrate with that slide the economical consequence of the drip loss. We took only a very small example, 0.5% of change of drip loss regarding only the breast meat. If we start with a 2 kilogram bird weight, live weight, it represents only 2 grams, I would say, of losses at the carcass level or at the breast meat level, which is less than 1 cent of a euro. But if you multiply by the normal, I would say a mid-size type of producer, about 1 million broilers a week, it makes quite a significant amount, 10,000 euro per week. And if you count on a year basis, it goes up to 500,000 euro for a producer. And this type of producer is corresponding to roughly 250,000 tons of feed per year. So it's a huge impact. In fact, just this 0.5% on the economic benefit of the poultry chain. So I think it's important to maybe to address first the focus on the losses, the drip loss, the cooking loss. And I would like to ask our scientific experts today to explain what is behind, in fact, drip loss and water holding capacity. So I say the first question could be the link between drip loss and water holding capacity. What is the change the muscle is facing going from muscle to meat? And what is the importance of the cell membrane integrity? And I think I could ask Massimiliano to explain a little bit more what is the transformation and what is the drip loss at the muscle level.
Okay, I think that first of all we need to say that meat is composed by 75% of water. So water holding capacity is very important technological property because it's the ability to retain its own water. And this property changes a lot during postmortem time because at the beginning water, just after the death of the animal, is contained inside of muscle fiber. But during transformation of muscle to meat, we have formation of extracellular spaces and there is contraction of the muscle due to rigor mortis development, and there is a squeeze out of water from the inside the cell to the outside of the cell. And water that are present in the extracellular spaces can be lost during storage or processing, especially if meat is cut. If meat is cut, there is a huge loss of water. And the drip loss is associated especially with post-mortem acidification rate, ultimate pH, and membrane integrity, as we will see later. For cooking losses, the situation is a little bit different because, of course, following cooking, there is a very huge loss of liquid, not only water, but also protein and fat. And there is two key points during cooking treatment. First of all, around 40 to 50 Celsius degree, we have a longitudinal shrinkage of the mussel, and these promote, of course, loss of water. But we have another key point during cooking treatment, because around 70 degrees Celsius we have a transversal shrinkage of the mussel, and then a huge flow of the water from the mussel to the external spaces. And if drip loss is very associated to ultimate pH, for cooking losses are also important the protein content of the meat, and especially the quality of the protein. Because, for example, collagen is not able to retain water. So, if meat is very rich in collagen, poor, especially very poor meat cut, both in poultry, pork and beef, we have huge loss of water. And so we have, of course, protein denaturation following cooking, but at industrial level, for manufacturing processed product, we have also addition of salt and ingredient. And salt and ingredient can help to bind water, its own water, but also water that are added during processing. And especially for drip losses is very important membrane integrity. Membrane integrity because, as explained before, water is entrapped, the majority of the water is entrapped inside the mussel fiber. So if it's possible to maintain as much as possible membrane integer, so in this way you can keep water inside the mussel fiber. But if there is loss of membrane integrity, there is also loss of water from inside to outside spaces. And to protect membrane integrity, for example, it's good to add vitamin E in the diet, because vitamin E is able to protect phospholipids that are in the cell membrane, and in this way to protect membrane integrity. And if we need to resume the factor that affect water holding capacity, we can say that overall it's very important the protein content of the meat and also the quality, especially related to the collagen percentage. Also are very important the protein charges. As we will explain later, protein charges depend on the ultimate pH of the meat. Protein denaturation that can happen during cooking, but can happen also during transformation of mussel to meat. So we will say that if pH is low and temperature of the mussel is very high, we will have a protein denaturation also in fresh meat. Cell membrane integrity, as explained, and only in further processed product, addition of salt and ingredient added during formulation. And water holding capacity is very important property because affects several properties of the meat. If you use meat as a raw material for further processing, water holding capacity affects processing yield, so there is a very implication on economical issue. Water holding capacity affects sensory property of the meat because if there is a huge loss of water during cooking, of course, meat is lost juiciness and can be also less tender. Nutritional value because, as I said before, there is not only loss of water, but within water there is also protein and fat, also in fresh meat. Shelf life because liquid inside the packages can affect appearance of the product, but also can promote microbial growth. And so water holding capacity is a very important property of the meat.
It's interesting what you said, Massimiliano, because you stress a lot on the protein aspect, so the protein quality. So I think we will see later on with Cécile about maybe the interaction on the amino acid supply and the meat quality. But I would like now maybe to ask another question, because we talked started to talk about ultimate pH. So what is the relationship between ultimate pH, water holding capacity, and drip loss. And maybe Cécile, I know that you are using very often this slide, but I think it's very important to explain to everybody what are the interconnection between these issues.
Okay, so as Massimiliano mentioned, the post-mortem pH fall that occurs after death in the muscle is very, very important. Maybe is the key parameters that determine water holding capacity in the meat. I mean drip loss, cooking loss, and even processing yield. So there is two traits during post-mortem pH fall. The first main character is the initial rate of post-mortem pH fall. That is measured usually at 15 to 20 minutes post-mortem. And it is in broiler and turkey much related to the activity of the birds on the slaughter at the slaughter plant. For example, when there is a lot of wing flapping, the initial pH fall will be very fast. And in this case, the meat produced will be called PSC meat for pale, soft, and exudative. And as you can see on the slide, this meat is very light in color, very exudative, and it will have also a very poor processing yield. The other condition is related to the ultimate pH of the meat. And in this case, the activity of the birds is not very important, but the main parameter which determines the ultimate pH of the meat is the amount of glycogen stored in muscle at death. If this amount of glycogen is low, the meat produced will have very high pH, and it will be called the DFD meat for dark, firm, dry meat. And this meat, as you can see, is very dark in color. It is very dry in the mouth because the water is very well conserved, and so it's not very good when you taste it. And a problem can be also the poor storage ability of this meat because of the high microbial evolution during storage. On the other side, there is the acid meat that is produced from muscle with high amount of glycogen. And for example, in the case of the breast of broiler, acid meat is considered as acid when the pH is below 5.7. And in this case, as the PSC meat, the meat will be very pale, exudative, and also will have a very poor processing yield.
So in broiler, we talk more about acid meat and I would say DFD meat than PSC meat compared to pork.
Actually, the PSC meat does not concern so much the broiler, but may concern more the turkey because of wing flapping, but also the fact that after slaughter, during processing of the carcass, the temperature remains high for a long time because of the weight of the animals. And there is a condition with a high temperature, a low pH, and in this condition, the protein of the muscle are denaturated. And in the case of broiler, this condition, because of the low weight of the broiler, is not the same because of the chilling procedure that decrease the temperature quite quickly.
So you mentioned turkeys. Do you mean that, for instance, heavy broilers would face the same issue than, I would say, big birds like turkeys, or it's totally different turkey and broiler?
I'm not sure there is any information about that, but for big broilers, I think processors, they have to manage well the chilling and the cooling procedure of the carcass to avoid this happens.
Okay, so regarding the ultimate pH, can you precise a little bit more? What does that mean really regarding the protein structure and so on?
As I said before, pH, especially ultimate pH, affect the protein charges distribution. As told by Cécile, if pH reach very low value, like 5.7, 5.6. So we can classify this pH as associated with PSC condition. In this way, pH is very, very close to the isoelectrical point of the protein, which is the means of isoelectrical point. Isoelectrical point means that positive and negative charges present on the surface of the protein are more or less the same. At this point, the ability to retain water is minimal in the meat because the structure of the myofibrillar present on the muscle fiber is very sticky, and in that way there is very low spaces available for hold the water within myofibrillar spaces. And so this is why PSC meat has a very low ability to retain water. As opposite, if the pH remain on value higher than 6, 6.1, 6.2, pH is very far from the isoelectrical point, so there is a huge amount of negative charges, and these negative charges can bind water, and structure is more open because of the repulsory energy in the muscle. So in that way, ability to retain water is higher. And these PSC and DFD are problem that we can find especially in poultry, but also in pork meat, while in beef we can find especially DFD meat. So it seems that both poultry and pork are more prone to develop PSC condition. This may be because especially breast muscle and loin muscle for pigs are composed especially of white fiber, and white fiber are more rich in glycogen, so during postmortem time there is higher production of lactic acid, and in that way pH can drop around value very close to its isoelectrical point. So the measure of pH, for example, is a way to understand if to determine the water ability of the meat.
So, in fact, more than talking about PSC and DFD meat, we should say acid meat. And how do you qualify the DFD meat? I would say high pH
yes.
meat, or but finally, it's more than PSC. It's acid meat in broilers. I would say in poultry. In pork, I understand that it's PSC meat, and they have the same issue regarding the dry, firm, and
I
dark
think
meat.
there was a confusion many years ago about PSC condition and acid condition, because really when you see a PSC or acid meat, for example, breast meat, broiler breast meat, they look the same and they have about the same traits. But most of time when we saw a meat with a light color and very exudative, it corresponds to acid meat, which means a meat with a low pHU. I would say maybe in Turkey it's a little bit different, because we know that in Turkey there is both condition, the PSC and the acid condition.
Maybe we can ask Paul again about what are the practical consequences of high drip loss, low water holding capacity for the poultry processor and for the slaughter plant. So maybe, Paul, if you can comment on that. What are the practical consequences?
For the poultry processor, we are facing two situations which are different from, are we on a tray retail pack, or are we on processing, further processing product? If we are in a tray retail pack, we can see in any country, in any tray, that there is more drip loss than there were many years ago. And now it is also very different. If you see on a tray, you don't need to look at the date or best before, because when you see the drip loss, you can say without any labeling how aged is the meat.
Paul, and do you think that the consumer at the end react quickly to those issues?
I'm not so sure, because you have It depends on the kind of tray you have. Is it vacuum bag? Is it skin pack? Is it you have a folder? So there are different ways to absorb it or not. And it depends on if it's transparent or not. It depends on how the product is displayed and shown to the consumer in the tray. That is on the marketing retail side. About processing, what we are facing is we can see when we are selling meat in bulk, I would say 500 kilo bag, that there are more or additional, it's not water of course, it's drip loss in the bag, but it depends after which kind of processing we are doing. If, for example, we are processing them to make a ham and we are taking out the water before processing, of course, there is a loss of yield. But if we are processing them, that is to say, for example, to make nuggets, and we are processing at a very low temperature, not negative, at very low temperature, drip loss are binding with the meat, and there is no effect.
So now, what are the solutions, I would say, to reduce drip loss? That's a main question that everybody has on the lips, I would say. What are the solutions to reduce drip loss? And maybe, Cécile, you can introduce first the ideas about the potential solutions.
Yes, so as we explained you, a main factor of variation for drip loss and I would say water holding capacity is the ultimate pH of the meat, which is related to the glycogen content. So solutions that can reduce, for example, the glycogen content of muscle will be efficient to reduce drip loss and cooking loss and improve processing yield. So for many years in RA, we have studied the factors that affect the glycogen in muscle. And we have found that there is two main factors, which are genetic and nutrition, but also some management practice that can affect this character. And so by modulating this factor, we think that it will be possible to improve meat quality and especially water holding capacity.
Let's talk maybe about more about genetic to start.
Yes. So genetic, it is interesting to know that in broiler, most of the quality traits, meat quality traits, are under a genetic control, and most of them are related to the ultimate pH of the meat. So for this reason, we have started a selection on these traits to look at the consequence for other meat quality traits, including drip loss and cooking loss, of course. So by studying this model, which represents finally meat with the acid pH and a meat with a very high pH, we were able to demonstrate that it is possible by this way to reduce the drip loss, to reduce the cooking loss, to improve by 3 points the processing yield, and also to improve the color of the meat.
That is a very good tool, in fact, a very good model, in fact, to work on the basis. How do you explain the ultimate pH and how do you correlate the ultimate pH and the drip loss and so on. So I think it's a very important model. Maybe Massimiliano, you can. Maybe you have other point to add on that. Sorry, Cécile. Maybe on the nutrition aspects, you want to comment a little bit more.
Yes. So if we can see that the genetic can be and selection on meat quality can be efficient, it is also important to understand how animal nutrition can modulate muscle glycogen and can modulate the ultimate pH of meat. So this was not really studied before, and we started some studies on different aspects, such as antioxidant or amino acid.
So maybe let's start with the antioxidant, Massimiliano.
Yeah,
because you talk
because,
about membrane integrity, huh? So I think it's a big issue.
Yes, because especially PSC meat condition is associated with pre-slaughter stress, especially pre-slaughter stress. So it is important to increase the tolerance of the bird to pre-slaughter stress and especially to heat stress. So dietary use of antioxidant, especially vitamin E and selenium, has been demonstrated that is able to increase the tolerance of bird, especially to heat stress, so to prevent or to mitigate the occurrence of PSC meat. But as I explained before, vitamin E and selenium can be accumulated in the muzzle, and this can prevent also the damages of membrane, and so prevent losses of liquid from the inside and to outside spaces. So antioxidant use in diet can have two effects. One, to preventing stress during pre-slaughter phases, and second, during processing, to prevent damages to membrane integrity. And also there are also some other studies that also tested also like natural antioxidant, and natural antioxidant can be effective but cannot be accumulated in the muzzle cell. So the use in the diet is not so effective like vitamin E and selenium.
So I'm sure that there will be quite a lot of questions about the strategy, nutritional strategy to work on that. How long should you supply the animal before the slaughter and so on? We'll come back later on that. We talk about antioxidants, and what about amino acids? I know that Massimiliano addressed the question of protein content and so on. Do you think that with amino acid we can affect the protein and affect the meat quality? Cécile?
Yes, actually, amino acid supply have been studied for many years in relation to performance and meat production yield. But several years ago, we start to look at the effect of amino acid supply on meat quality traits. And a first study demonstrates very well that supplementing birds with lysine was able to increase breast meat yield, which was well known, decrease also body fatness, but as a very interesting result, we were able to show that it also decreased drip loss by increasing the ultimate pH of the meat. So after this promising result, we tried to figure out the relationship between the amino acid balance in the diet and the ultimate pH of the meat. And we designed several studies to look at the response of birds in terms of ultimate pH. And what we demonstrated is that the balance of amino acid can really change the amount of glycogen in muscle with real impact on meat quality. And this is very efficient because by changing the amino acid balance during 3 days before slaughter, we were also able to change drip loss and processing yield of the meat.
Okay, that is very interesting. But if we look at maybe the type of results you obtain, what could be at the end the consequence and the practical consequence at the animal level?
So the consequence for meat quality was, of course, significant. But with our partner, we tried to look at the calculation regarding the cost and the gain we can have by feeding birds with a good amino acid balance. And what we found is that if the diet is well done to produce meat with a high pH, we can, compared to the control, we can gain about 100 euros per ton of meat produced. And on the other side, if the diet is not well designed and make to produce acid meat, the loss can be very high because it's almost 400 euros.
So, in fact, in some way, you say that the difference or the variation could be up to 600 euro, per ton.
Yes, it's
but
500.
I would say in practical conditions, do you think that people can use that strategy today, or is there still some refinement to develop on how to practically use that?
Actually, I think our study is not a ready-to-use solution because people, they have to adapt their nutritional strategy to the ability of bird and to the physiological capacity of birds. But it clearly showed that a diet that limit protein synthesis and increase energy storage is not good for processing yield and for drip loss. So I think by this knowledge, it can help nutritionists to design a diet and to help to produce meat with higher pH and at least less variable pH.
So we really need to understand better, in fact, the evolution of the nutrition prior to slaughter and really play a little bit more with the feed formulation and to really see up to the benefits and maybe without too much impact on the feed cost at the end.
Yes.
So that's a dream, but I think it's...
No, that's not a dream because in these experiments, we have made several. The cost of the feed was not really increased because we increased lysine, but we decreased the other amino acids. So the cost on feed was very low. But by adding all the benefit we can have all along the chain until the processing, we can have a very high benefit. And I think now it is important to not only calculate the benefit on the breast meat yield, but it is also important to consider all the waste and all the losses after slaughter.
And after you also worked on specific amino acids to see if there was some effect on some amino acid, like sulfur amino acid, I would say, on through their antioxidant potential. So we consider first the amino acids as just break of construction, but also maybe the roles beyond this protein deposition. So as antioxidant, for instance, can you comment a little bit more on what you did on that issues?
Yes, sulfur amino acids are very interesting because, as you said, they are amino acid to build the protein, but they have also a specific role on the antioxidant response. And by these two ways, I think they are able to improve meat quality because they will protect the protein from oxidation, but they are also able to modulate the ultimate pH of the meat. And this was demonstrated in an experiment by using the HMTBA instead of classical methionine. And we were able to show that by using it, both the ultimate pH was increased and oxidative stability was also increased with a positive impact on meat quality, especially drip loss.
So still some work to do on amino acids,
yes,
in fact, to improve.
Of course, but I think nutrition has to be studied in relation with, of course, performance and feed efficiency, meat yields, but really nutritionists has to consider also meat quality in their study.
Yeah. It's very interesting that you demonstrated both that you could manipulate, in fact, the meat quality by the previous diet before slaughter. Maybe I will ask Paul now, in the practical conditions, do you measure drip loss in slaughter plants today? Because that's a main question we have very often.
I cannot speak for anybody in the supply chain because I would say, only working in one plant, even if I'm visiting a lot of them. In the plant where I'm currently working, we are not measuring, but we have a quite good view of it. Is it more important or less important? What I can tell you is changing from every day, within a day, within a flock.
We ask to Cécile and Massimiliano if they had some ideas about solution to reduce drip loss, but I would like to ask the people from the industry also to say, do they have found a way to reduce drip loss? Have they found solutions to reduce drip loss? So Paul, if you can objectively, I would say, answer to that question, do you have a solution to reduce drip loss?
Very interesting question, because I have no real answer. If we would, I would say, as a joke, if we would know about it, either it would be a secret, either we can better say that we don't know really. We are facing this changing situation all the time, but it is more, it's bigger than it was some years ago.
Paul, as you are a European representative of the poultry processor, I would have a question. Do you think that we are all facing the same issues in European countries? And I think your feedback from the field is interesting on that.
Yes. And what is easy, I am not a scientist, okay, but I am traveling a lot. And I can say anywhere that you have drip losses in a retail pack. So we are, all of us, facing the situation. Maybe also we could say that as heavy or heavier the birds are, maybe the percentage is a little bit higher. But of course, as a piece of meat are bigger, there is more drip losses.
Okay.
To be back, excuse me, to be back on facing the situation from country to country. I am speaking about the European side, because we are air chilling, and it is really totally different in some countries on retail pack where you are water chilling, because it is an adding.
Yeah, we say at the beginning that we are focusing on drip losses. We don't talk about, I would say, the breast meat default, myopathies, and so on. But it's interesting to see, is there a link between the current breast meat defaults and what we have talked before, drip loss and water holding capacity? So Massimiliano, maybe you can comment on that.
This is an interesting question, because market is pushing to have heavier bird because of the increased demand for cut-up and especially processed product. So, as demonstrated by Cécile in several studies, if you increase the slaughtering age, there is a decrease in glycogen content in the muzzle, so there is an increase in pH. And this may be associated to an increased water holding ability, as explained before. But overall, you may see a decrease in water holding ability. Why? Maybe because there is an increase in occurrence of abnormality, like, for example, PSC meat, because heavier birds are less prone to tolerate heat stress during pre-slaughter time, but also because if you increase slaughter age, you can have also an higher occurrence of breast myopathy, like white striping and especially wooden breast. And if we look at the pH of wooden breast, we can see that the pH is higher than normal, more or less very similar to DFD condition. So we can expect that wooden breast can have a very good water holding ability. And if we look at data on drip loss, value are not so different in respect to normal meat, but if we cook wooden breast meat, we can observe a huge flow out of liquid during cooking. And this especially because there is a reduction of protein content in woody breast, and this is the main cause because of the reduced water holding ability of woody breast. So in this case, there is no pH effect, but there is a protein effect that affect water holding ability.
So really all the parameters, the characteristic of meat quality are interrelated. And we should not forget the second question at the initiative of this webinar about meat color. So in fact, because you talk about dark meat, pale meat, and so on, we talk about acid and non-acid meat and so on. So what are the relationship between meat color, stability, and drip losses? Massimiliano.
Okay. In general, if we consider color, of course, color depend on the amount of myoglobin in the meat. So if we compare breast meat and leg meat in poultry, of course, breast meat is lighter in respect to leg meat because of the lower content of myoglobin. But we need also to consider the atmosphere of packaging that affect the color, because if meat is packaged under vacuum, like for example for market exchange, there is a very low pressure of oxygen, and in this way there is prevalence of myoglobin, native myoglobin, so the color is red purple. But if we expose meat to high concentration of oxygen, like ordinary atmosphere, or like modified atmosphere packaging, we increase the rate of oxygen, and in this way we promote the formation of oxymyoglobin, so is the color that we are more familiar with the meat. But if both kind of myoglobin undergo oxidation, there is a loss of color because there is formation of methmyoglobin, and in that way there is both discoloration and darkening of the meat. And we can also say that there is a third factor that affects meat color. Why breast meat with PSC abnormality is paler than breast meat that is affected by DFD condition? Because the myoglobin content is the same, so there is no effect of the amount of myoglobin. But meat that have different pH value have different property in interaction with light. So if meat has a very high pH, light is able to penetrate in the depth of the meat, and in this way there is a high proportion of absorption of the light by myoglobin, and meat became darker. Otherwise, if meat has very low pH, like when we have PSC condition, light is not able to penetrate inside of the meat, so we have poor absorption of the light, and meat appear to be very pale. So there is a relationship between color, if we consider the same muscle, and water holding ability.
It's interesting because you focus quite a lot on red meat, I would say,
Yes.
either pork or the thigh and drumstick. But what about the breast meat? Because we are not talking about red meat. So how do you explain the change in color? It's maybe not planned at the beginning, but
Okay.
I think in the case of broiler breast meat or Turkey breast meat, the main factor of variation for color is pH, and it's very when you go in a slaughter plant and you can see all these bread fillet together, there is a huge variability, which is really a problem for retailers, especially when you sell cuts, and when you measure the pH of these cuts, you can do a very nice relationship and a very linear relationship between lightness and pH. So I would say that because of all these factors of variation, I mean genetic, nutrition, management that affect ultimate pH, you will also affect the color in slaughter plant. And I think it's really a challenge to control both of them.
It's interesting. So we run a trial with a poultry processor a few years ago, and we addressed the color stability also. It was on a turkey meat, on brochette with thigh and drumsticks. And again, we looked at first how to stabilize, in fact, the brochette. I would say, as an anecdote, in France, the weather is not always constant. So you prepare the brochette, and after a couple of days, the weather change, and then the brochette stay in the retail shops, and then the colors change, and people do not want to have any more this type of meat. We try to prolong, and in fact, what we realize, it could be possible with antioxidants like organic selenium and so on to go further, to maintain the color a little bit further, say 1.5 days, something like that. But we also end up with a question of ultimate pH at the end. And we say maybe there is an interrelationship with the ultimate pH. Maybe we could ask, in fact, what is a practical situation in slaughter plants, about the meat color? And I would like to ask Paul, what are your comments on that regarding the meat color and from your field experience?
Once again, I would say we are facing, even within a flock, color differences. Of course, we have some flocks from day to day, from flock to flock, which are with more darker meat or not. But the major things is it is usually within a flock, and we have to take care of it, because if we want to make a nice tray, we have to be sure there is not one dark and 5 light, with light colors. And for processing, it's not the same issue, because as we are mixing in 500 or 1 ton bag or batches, it's more distributed.
Yeah, Paul, is there a demand from your customers about this meat color stability, improving the meat color stability? From your customers, do they demand that?
I would say no directly, but of course, on the impression you have on the consumer, are they buying or not, or buying once again. But I have nothing to measure it. But what we are facing is sometimes we have some pieces which are darker than the others, and that can create some troubles.
It's interesting to see that in the industry we don't measure things and so on, but we are paying the consequence. If people are not rebuying from the same shop or from the same packaging and so on, so that there is an issue. Now we are opening the time of the round table. I think many questions arrived during your presentation, and we will try to answer to most of them, I hope. To start, I suggest to take the first question. Yes, how to measure? It's a good point after the question from you both and from Paul. How to measure drip loss in slaughter plants? Could we imagine a predictor based on a rapid measurement technology? What do you think about that? Can we translate what we measure in the university to what we can observe in the field? Really, your feedback. Who wants to start?
Yes, I can. Maybe I think that there is several techniques, especially spectral techniques. As we told you, there is a nice relationship between a high relationship between color and drip loss or water holding capacity. So measuring color in slaughter plants, color of the meat, can be a good good way.
More feasible than the drip loss per se.
Yes, but even if the problem is the cadency in the slaughter plant, because it's not like pork. These developments have been possible in pork for many years now, but in a broiler slaughter plant, because of the fastness, it's quite difficult. But I think spectral tools can help to determine drip loss.
In fact, I would say to fit with the speed of the chain and so on, maybe we need to have something to measure at distance. Really
yes, of course.
Observe quite enough to see the change going on and so on. You have any comments, Massimiliano, on that?
For example, for turkey, it's easier to develop this system because of the bigger size of the breast. So in that way, we can in turkey is more easier also because the speed of the processing line is lower than for broilers. And Also, in slaughter plant, it is possible measure parameter like pH and drip loss also under laboratory condition. Okay, I think that is very important for slaughter plant. Have a laboratory equipped with a pH-meter, because the measure of pH is very important. So you can understand if pale color is associated with lower pH or not, so you can understand better which is the causes of the paler color. And also it is possible to make some test of drip loss also in the company.
I'm thinking about the ultimate pH, because you say there is a threshold. You say below that 5.7, above 6.1, 6.2. Why not to have an indicator, stick on the breast, I would say, and changing color when you are below or when you are above, and then you know that it's green or red. Would that be possible?
It's very difficult because pH measurement is low. You need some second to read the pH, and you need also the contact. And when you have contact, there is also a risk for contamination. So while if you measure color, you have no problem about contamination, and also the speed now with the very powerful computer, it is possible also to manage images.
Okay. I think it's important for the future to try and to work on tool development for the slaughter plant, but really I think maybe it will be also efficient to work on the factors that affect all these traits, to be sure that when the broiler arrive at the slaughter plant, their characteristics are the good one.
Good one. So maybe we can jump on the next questions from the web. Yes, how are linked the various drip losses? Water loss during meat storage at 4 degrees, cooking loss, freezing loss, and I would say sewing loss and so on. All the loss.
As I told before, my experience, drip loss is very associated with pH and of course membrane integrity. These are the two key points. For cooking losses are also important the protein content and quality. So there is an association, but are two different characteristics of the meat. And about freezing losses are very associated to the technique of freezing. So if you have very efficient technique, you can have very small size of the ice crystal, and in that way damages of the muscle fiber is very low. So there are some relationship, but you can have also sometimes different behavior.
The discussion is very interesting, but the time is flying, I think. Maybe we can take another question. What is the practical situation? I would say, what is the main solution to reduce drip loss, and what type of development we can expect in the future to reduce this issue?
So I think we.
So if you get the solution, as you say.
No, we don't. Actually, I think research can help to understand which factors are controlling drip loss, and to better understand how nutrition, how genetic, how bird management can help to control the bird metabolism, and also the bird oxidative stress, which is very important, can help to improve meat quality, including all drip and cooking loss.
Okay, any more comment, Massimiliano?
No, in general, we see that diet before slaughter is very important, pre-slaughter handling before slaughter is very important, but also processing, slaughtering technology is very important, stunning procedure, but also chilling, application of electrical stimulation. So there are many points that can be controlled to reduce as much as possible drip loss, because a certain amount of drip loss is natural. So we cannot eliminate drip loss, because this drip loss is normal in meat.
Okay, thanks for both of you. The time is flying, really, because we enjoy the discussion and the presentation and so on. I would like to say that we will receive questions, and in fact, we will answer to the questions later on. So I will drop the question to both of you, and we will prepare the answers to post on FeedChannel. I would like to first warmly thank our speakers and Paul from a distance, but I think it's quite interesting to share experience. And all the participants, you will be able to listen again to the presentation through podcast, and also to ask your question and see the answer to your questions on FeedChannel.online. Don't be disappointed if your question has not been raised, but the time is really flying. We hope you enjoy this webinar, and we give you next appointment in December to have a live webinar on amino acids. So really, bye-bye everyone, and looking forward to seeing you on next December.